All right, so what we're talking about in this video is transformations. That happens with a, h, and k. This is our parent function right here. F of x is equal to the absolute value of x. No numbers, nothing like that, just the basics. And then here's where it's going to transform. That means where it's going to slide, reflect. It's going to change in some way. And so when we start to add values for a, h, and k, that's when it's going to start to move around the graph. And cool things will happen. Let's take a look at some of the things that might have happened. So here's the parent function. This is the most basic. It goes through the center, lives at the origin, but then we add a +2. Which letter was that? Was that A, H, or K? Well, I notice it's at the end. It's outside the bars, so that must have been K is my guess. So it means K here equals 2, and what happened? It used to live in the center, but it's no longer in the center. It looks like it's up here on the y-axis at 2. All right, let's take a look at this one. -3, that's at the end. It's outside the bars. That also must be K. So I'm going to write K is equal to -3. So this guy was in the center, but this guy's not in the center. He's down here at -3. Oh, that's interesting. So the K value kind of matches where it crosses the y-axis, it looks like. So I guess let's look, 5, it's on the y-axis at 5. Yeah, so it is doing something like that. K is equal to 5. And what did these do as we changed the K value? It looks like it started in the center and the graphs just go up. What caused it to go up? Positive number, +2. Okay, so if you have a positive K value, the graph shifts up. This guy's negative. What did he do? He shifted down. Positive. Let's see. Yep, it went up again because there's the origin right there. Okay, so I guess if K was the letter change and it's positive, it's going to go up. And if K is a negative value, this is going to shift down. All right, let's go look and see what happened on the next line here. All right, so this time the number being changed looks like it's on the inside. So which one's on the inside? I'll write the equation here. A, absolute value, x minus h plus k. So now if it's the number inside that's changing, that must be the h value. What happened here? I like to call this guy the liar, and here's why I like to call him the liar. Because remember on K, when it was positive, it went up. When it was negative, it went down. That makes sense intuitively to me. When something's positive, it should go up, and when something's negative, it should go down. But look what look what H does, the liar. And this guy is -2. Remember, the parent function lived at the center. Where did this guy go? Looks like his vertex is over here at 2. So then let's see, this guy is +3. Remember, he used to live in the middle. That was the parent function. Where's he at now? -3. So this one's kind of counterintuitive. It does the opposite of everything we think. So if this guy tells me -5, I'm going to call this guy a liar. I bet he's really at +5. Here's where the parent function was at the origin, and look at that. Sure enough, this guy's over at +5. So we could graph this last one. I don't think we need to. The letter changed here is H, and it does the opposite of what we think. When it's positive, it actually goes left to the negative numbers, and when it's negative, it actually goes right to the positive numbers. So H is a liar. Let's go see what the next line did for us. All right, this one's in place of the A value. Y equals A, absolute value, x minus h plus k. Now we're going to change the A value. This one's to 2. Now this one's kind of hard to tell, but the parent function, I guess I'll write it in red so you can see the difference. Started off in the middle. This one's still in the middle. Then it went to 1, 1, 2, 2. So it's kind of like that. -1, 1, -2, +2. Here's the difference between this one. This one got narrower. So the idea is y equals, here's the parent function. What did the A value used to be? It was 1. So the A value is kind of like the slope. It's the rate of change. It's how fast things are happening. If you rode down this red line on a sled, maybe it's snowing outside, you're not going to go as fast as you would where A value is 2. It's a little steeper, so you're going to go faster. The bigger the number for the A value, or the bigger the number for the slope, the faster things are happening, the steeper the line is. So Now let's go check out the A value. What happens if it's negative? This one was positive, but now this one's negative. The rate is the same because we still have that value of 2. It's just now this guy is upside down. So we're riding the same hill upside down. So it reflected it. It's still in the middle. So notice the A value doesn't move it up or down or left or right as far as shifting goes. But if it's negative, it can reflect it down. Big difference between shifting and translating versus reflecting. This guy's -6. Negative means he's upside down, and 6 is a bigger number than 2. So now look at this, even steeper. Well, that's an even faster hill to go down. Now compare this 2 to this 4. It's positive, right? So it's going straight up. But 4 is a bigger number than 2, so that's going to be a pretty fast hill to go down. So the A value is the steepness, and the A value tells us is it reflected up or reflected down. All right, let's go look at how the A, H, and K can help us write the equation. I've got a bunch of V's here. Oh my goodness, look at them all. Let's first identify the vertex. I want you to know that the vertex is H and K, and the slope, that is your A value. Now the equation is, oh, there it is, I already wrote it. Y equals A x minus H plus K. If we can go figure out the vertex, let's just take this red line. The vertex here, the coordinates are 3, 4. 3, 4. Well, the first value is the H and the second value is the K. So now we know H is 3 and K is 4. The A value we said is like the slope, the steepness. That's just rise and run. You're always going to start at the vertex. You're going to go to the right until you hit the corner of a box. See how this meets right at the corner of that box? I didn't stop here because there's the corner, but this guy's in the middle. He's not on one of the corners of the boxes. So you have to trace to the right until you hit a corner of a box. So you can get, let's say you were trying to get coordinates. You want to be able to get good coordinates. If we were here, we'd be able to call this 4 and 6, and those would be good coordinates. Now for us, what we want to know is the A value of the slope, and slope is rise and run. So we rose 1, 2 boxes, and we ran 1 box. So the slope would be 2 over 1. Fractions are division. 2 divided by 1 is just 2. So now to write the equation, once we have A, H, and K, we're going to write Y equals 2x minus 3 plus 4. So I just put the A, the H, and the K values into the equation. So this is the equation that describes the red line. Did it do what we thought it would do? Yeah, it's a little bit steeper. This guy says he's at -3, but where's the vertex really? He's at +3, so he's lying to us. The K value's 4. What happened with the vertex in this V? He used to live here, but now he rose 4. So that makes sense. That kind of did what we thought it was going to do. Let's go look at another one of these. This time, let's go with, how about this one that's upside down? What are the coordinates there? This would be -3, 1. All right, so that's our H and K, right? That's the vertex. So we're going to write -3, 1. The slope, rise and run. So I got to go to the right until I hit the corner of a box, and it looks like I do it right there. So this time you're going down. So down 1, down 2, down 3. That means -3. And then we run 1 to the right. That's +1. So the A value here is going to be -3. That's the rise over the run is +1, which equals -3. And that makes sense that the slope is negative because this line is upside down and we have a negative A value. It reflects downwards. All right, so let's fill this in. Y equals -3. Now notice this guy has a minus sign in here. And our H value is negative. So negative times a negative gives me a positive in here. And that'll be +3. And then the K value is +1, so we'll write +1. Now let's see if it did what we thought it would do. If it's a negative slope, yeah, it's upside down. This guy says he's at +3, but where is he really? He's over at -3. And this guy shifted up 1. Yep, so we did everything we needed to do. That's one way to check. I didn't do domain and range for this. Maybe we'll talk about that later. I think you're pretty good at that. Let's just do one more of these writing the equations. Maybe two more. Let's do, I don't know, how about the green dash one? Is that green? I think that's green. This guy's at 3, 0. That's our h and k. The slope, so we're going to do the green line until we hit the corner of the box. That's there. Up 1, up 2, rise 2, run 1. So the a value is 2 over 1, which equals 2 when you divide it. Filling this in, that would be 2 there. The h is positive 3, so this guy's going to lie and tell me negative 3. K's is 0. I don't actually need to write a 0. That's kind of a waste of my time, so I'll just leave it blank there. All right. How about another one? I'm going to put the dot in the same place for the vertex, but this time I'm doing the upside down V. So what are the coordinates? Still 3, 0. But this time, let's look at the slope. We're going to go to the right all the way to the corner of a box is right there. For this one, we have to go down 2. That's negative 2. And then we have to run 3. That's a positive 3. So the a value, there's h, there's k. The a value is going to be negative 2/3 this time. So the equation is y equals negative 2/3 x. If he's positive 3, this guy lies, tells me negative 3. And again, the k value is 0, so we don't need to write it at the end. So we can determine the equation from the a, h, and the k, and we can determine the transformation, how it shifts, translates. That kind of means the same thing, slides, or how it reflects if the slope is negative.